Hello everyone, welcome back. Today's subject is PCS and the topic is about pulse code modulation. So, pulse code modulation with line coding is a digital representation of an analog system where the signal is sampled, quantized, and then encoded into digital bit stream. Line coding is a method used to convert this digital bit stream into a form that can be transmitted over a communication medium. So there are few steps in line coding. The first is sampling. The analog signal is sampled at regular intervals to create a series of discrete values. The sampling rate must be at least twice the highest frequency present in the analog signal to avoid analyzing. So the second one is quantization. Each sampled value is approximated to the nearest value with a finite set of levels. This process introduces quantization error, but it also allows the analog signal to be represented digitally. So the third is encoding. The quantized values are then encoded into binary format. Each quantized value is represented by a fixed number of bits, resulting in a digital bit stream. So, line coding. Line coding is a process of converting the binary bit stream into a signal that can be transmitted over a physical medium, such as a cable or through the different air. Different line coding schemes have different properties and applications. Common line coding schemes. The first is non-return to zero. So NRZ level is a binary 1 is represented by one voltage level and binary 0 by another. The signal does not return to 0 between bits. NRZ inverted. A binary 1 is represented by a transition in voltage while the binary 0 has no transitions. So the second is return to 0. The signal returns to 0 between each bit. This makes synchronization easier but requires more bandwidth. So the third is Manchester encoding. Each bit period is divided into two halves represented by high to low transition, a binary 0 by a low to high transition. This provides good synchronization and error detection. The fourth is bipolar encoding. Binary 0 is represented by no line signal while binary 1 is represented by alternating positive and negative voltages. This helps to reduce the DC component of the signal. So the fifth is 4B or 5B encoding. Groups of 4 bits are encoded into 5-bit symbols to ensure there are enough transitions for synchronization. So the advantages of line coding are synchronization, error detection, and DC balance. Synchronization. Line coding schemes often include features that help the receiver stay synchronized with the transmitter. Error detection. Some line coding schemes can provide error detection capabilities. DC balance. Certain schemes like bipolar encoding ensures the signal has no DC component, which is important for certain transmission media. So, applications of it are telecommunications, data transmission, and digital audio and video. So, telecommunication. PCM with line coding is widely used in digital telephony and voice over IP data transmission. Line encoding techniques are employed in various data transmissions standards, including Ethernet and digital subscribers line technologies. And the last one is digital audio and videos. PCM is used in digital audio and video formats such as CDs and DVDs. So, example workflow are analog signal and analog signal is received, sampling. The analog signal is sampled at the rate of 8 kHz. Quantization. Each sample is quantized into one of 256 levels, which is 8 bits per sample. Encoding. The quantized samples are encoded into 8-bit format. Line coding. The binary bit stream is converted into Manchester encoding, encoded signal for transmission over a Ethernet cable. So, conclusion is by using PCM with appropriate line coding, high quality digital communication can be achieved, suitable for a wide range of applications. Thank you for watching.